You've seen these your whole life. On every circuit board inside your camera flash, that big silver can in your air conditioner, it's a capacitor. It stores charge. And here's the key. It takes time. That time is the RC constant. So what is it? Two metal plates close together that store electric charge. The charge they hold is capacitance times voltage. Q equals C times V. Push charge onto those plates, and the voltage across the capacitor climbs higher and higher. But unlike a resistor, it doesn't just pass current. It charges up, and then it blocks steady DC. Now let's charge one. Wire it to a battery through a resistor and close the switch. Current flows, charge piles onto the plates, and the voltage rises. But not instantly. It follows a curve, fast at the start, then slower and slower as the capacitor fills up. How fast? That's the time constant. Tau equals R times C. Ohms times farads gives you seconds. And here's the magic number. In one time constant, the capacitor charges to 63% of the supply voltage. Make the resistor bigger, or the capacitor bigger, and it charges slower, a longer tap. The curve is exponential, a big jump at the start, then it eases off toward the top. 1 tau gets you to 63%, 2 tau, 86, 3 tau, 95, 4 tau, 98%, 5 tau, 99, and we just call that fully charged. So after 5 time constants, the capacitor is basically full. That's the rule worth memorizing. Let's do a real one. A 10 kilo ohm resistor and a 100 microfarad capacitor. Tau equals 10,000 times 0.0001. That's 1 second. So after 1 second, 1 tau, the cap sits at 63% of 12 volts, about 7.6. After 5 seconds, 5 tau, it's reached essentially the full 12 volts. Want it slower? Use bigger parts. A 1 mega ohm resistor with that same capacitor gives you a tau of 100 seconds. Discharging works the same way, just inverted. In one time constant, the voltage falls to 37% of where it started. So remember, tau equals RC, 63%, and 1 tau full in 5. That one idea runs timers, camera flashes, and filters everywhere. Next time, we leave the theory board and tackle another real-world problem you've searched for. Grab a pencil, and I'll see you at the board.